question 12 gives us two separate parametric equations, asks us to find their Cartesian equations and coordinates of the intersections with the axes, and then sketch the two curves, indicating clearly the equation of any asymptote. So let's take a look at 12 part 1. We know that x is equal to t squared, and that y is the square root of t to the 4 plus 1. So this is quite nice because we can see the equation for x appearing inside the equation for y. So the Cartesian equation is going to be y is the square root of t to the 4 is t squared squared, so this is just t squared, x squared plus 1. And again, we can simplify this further. That gives us y squared is equal to x squared plus 1, or y squared minus x squared is equal to 1. We recognize this now as the equation of a hyperbola. So this is a hyperbola. What can we say about it? Its center is 0, 0. The distance from the center to the vertex is 1, so our and this is also a vertical orientation, sorry. So our vertices are going to be 0, 1 and 0, minus 1. And to find the asymptotes, we just, instead of, as x and y get very large, the 1 matters less and less, so we get y squared minus x squared equals to 0. That gives us y is equal to plus or minus x as our asymptotes. So what will this one look like? Please forgive me, this is going to be a little bit messy. I think you're used to it by now. X, y. So I need to have my first asymptote, y equals to x. Another one, it's a bit not so nice, but oh well. Y equals to negative x. Vertical orientation, so it's going to look something like this. Sorry, that shouldn't actually touch my asymptote. I've been a bit bad there. 0, 1. And that is 0, minus 1. So that is 12 part 1. What about part 2? So 12 part 2, instead we have the equation x is equal to negative 2 secant theta, and y is equal to tangent theta. So to sketch this one, to find the Cartesian equation here, I'm going to use the fact that 1 plus tangent squared is equal to secant squared. Now you may say, how do you know that? Well, I don't have it memorized per se. I just remember sine squared theta plus cosine squared theta is going to be 1. And to get a tangent, I'd need to divide everything by cosine squared. And that gives me tangent squared theta plus 1 is equal to secant squared theta. So that's the relationship I'm going to use. So we can see that secant theta would be negative x over 2. So what does that mean? Tangent squared plus 1. That means y squared plus 1 is equal to secant squared, x over 2 squared. And what that actually means is that x squared minus, sorry, x squared over 2 squared minus y squared would be 1. So again, this is a hyperbola. Again, the center is 0, 0. This time, however, it is a horizontal orientation because the x squared minus y squared. So, and we've also got a 2 down here, which means that its vertices are going to be 2 units from the center. So the vertices are going to be 2, 0, and negative 2, 0. What about the asymptotes? Again, we'd solve this equation, x squared over 2 squared minus y squared equals to 0. We get y is equal to plus or minus 1 over 2x. So what does that look like? Y x 1 over 2x, so the asymptotes are a little flatter this time. This is y equals to negative 1 over 2x, y equals to 1 over 2x. That will be our point 2, 0. This can be our point negative 2, 0. And this is roughly what we get. Again, I expect you guys to do a neater job where you have pen, paper, and ruler. But yes, that is roughly what it should look like. Just checking against the answers, I noticed I've actually made a mistake back up here. And it was a very subtle mistake. But if you look at this has an implication. This implies that both x and y should be bigger than 0. So this is what I didn't take into account when I was actually sketching it. So it will definitely have the shape of a hyperbola, but it won't have the shape of the whole hyperbola. Sorry, I did say bigger than 0, I mean bigger than or equal to 0. So that intersection point down here just won't happen. And our graph, it will look roughly like that of a hyperbola, but it will only be actually there for this portion of it. The other portion would not happen because your no matter what your t value, x and y should remain positive. So you only get this portion here in the first quadrant where x and y are positive. So please take note of this error.